You know what time it is. EOC bell work number 9. Guys, we're down to the single digits. Woo! Are you excited? Get excited. Yes! Okay, so you've had a few minutes to take a look at the question. And so it says, describe the difference between a rational and an irrational number, okay? Give an example of each. Okay, guys, well, we're going to go down memory lane super quick, okay, to our classifying numbers lesson real quickly, okay, where we know that all numbers fall under the umbrella of real numbers, okay? And we started with natural numbers, right? I told you to think of money because natural numbers start with the number 1, 2, 3, and go on into the positive direction. And then our whole numbers, okay, start with 0 and go 1, 2, 3 on into the positive direction. And then our next category is integers, where you have the negative side of the number line represented. Okay, the positive and negative sign of the number line represented. Okay, and then we go into rational numbers and irrational. So let's talk about that. My spelling. Okay, let's talk about that for a second, okay? So the definition of rational, okay, numbers, I'm going to bring it up for you so that it's all official for you. The official definition, okay, says that rational numbers can be written as a ratio of two integers, a ratio meaning a fraction, something over something, a ratio of two integers with a non-zero denominator, meaning it's a fraction where 0 cannot be in the denominator, okay, and irrational numbers cannot. So, for example, the number 7, everybody write that down. You're writing this as I'm writing it in your bell works, okay? And so how can we express the number 7 as a ratio of two integers, okay? We can write this as 7 over 1. We can write it as 14 divided by 2. We can write it as 21 divided by 3, and so on and so forth, okay? So you guys get the idea. A rational number can be written as a ratio, okay, of two integers where the number in the denominator cannot be 0. But I want to take it a step further, and I want to remind you that a rational number, in this category, we also include perfect squares, okay? The square root of 25, it gives us 5, okay? Perfect squares fall into the rational category. And then we have terminating decimals, okay? Where, like, if you were to, punch something in the calculator and you got 2.3 as your answer, well, that's a terminating decimal, which means that was the answer you got. It stops right there. Nothing additional beyond. Okay, we have a terminating decimal. That is part of the rational category. And then we also have, like, if you used your calculator and took the square root or did the division and you got 0.444, and it kept going and going and going, okay, we call that a repeating decimal, right, where you put the bar above it. That would also be considered rational, okay? So we have a decimal that terminates and then repeating decimal. Well, conversely, okay, in the irrational category, you would have something like the square root of 11, a square root of a number that is not a perfect square. Remember, with rational, we had perfect squares in the rational category, so we have radicals that are not perfect squares. And then what is the most famous decimal that we know of that just continues on forever, well, that would be pi, right? It's 3.14 and it goes on and on and on and on. It never ends. It never terminates. So it just keeps going on and on and on. That would be considered in the irrational category, as well as another decimal like that does not repeat. So in the rational category, we had a repeating decimal, but in the irrational category, we would have a non-repeating decimal like 101001000100001, and so on and so forth. You get the idea. So that's the difference between rational and irrational with examples of each. Okay, that was EOC Bell work number 9. Great job, you guys.